Good morning or good afternoon, whenever you're watching this. We've talked about translations. So our next type of transformation we're going to talk about is reflections. So a reflection is a transformation that creates a mirror image by flipping the pre-image over a reflection line. Reflection line is a line that a pre-image is flipped over to create its image. Usually the reflection line is going to be the X or Y axis. However, there are some times when we have some different lines, which we'll talk about. So up first, basically we have a X-axis, Y-axis, coordinate grid. We're going to talk about reflections. Pretty simple. All it is, if you've got a point or you've got a shape, say you have your point there and it says reflect, and your problem is reflect it. Just switch to make this thinner. Reflect point A across the y-axis. So then we'd say, okay, this is the y-axis. So it's like a mirror. We're going to reflect it to the other side. So point A is going to turn into A prime, and it's going to be the exact same distance away, just flip to the other side. So if we looked at this, we'd say, okay, how far is point A? If we're going to reflect it, across the y-axis, how far is point A from the y-axis? So point A is 1, 2, 3 spaces away. So point A prime is going to be 1, 2, 3 spaces away on the other side. And that's it. That's all we're doing. Reflection and translation are the two easiest ones. Shouldn't take much time at all to go through this, but that's basically all you're doing. So we've got right here, we've got point B. If I said I want you to reflect it across the x-axis, all you're going to do is say, okay, how far is it from the x-axis? 1, 2. It's 2 spots from the x-axis, so it's going to flip over it, and it's going to flip the same exact distance. So point B is now B prime. It's 1, 2 away, so it's 1, 2 away. You just flip it exactly the same distance across. That's all you're doing with reflections. Now, make sure don't look at this and say, okay, this is easy, I got this, and then turn the video off, because we've got some harder, more difficult ones coming up. But we won't do too many of these. Let's do one more. Let's say you've got this point right here, point X, reflected over the y-axis. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, where students make a mistake is they get in a hurry and then they end up miscounting. So just be careful. Count, make sure 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That you're the same distance, so you don't end up with that problem. So you could be reflecting one point, or you could be reflecting a whole shape. So we've got triangle RXD or DRX, or however you want to say it. We want to reflect it across the x-axis. So the x-axis is this axis right here. So all we're going to do is the same thing, but we're going to count for each corner of the triangle. So if we go with point R, 1, 1. So there's R prime. For X, 1, 1. There's X prime. And for point D, 1, 2, 3, 4. 1, 2, 3, 4. D prime. So now that we don't just have a point, but we have a whole shape, you can see how the shape's going to be the exact same size. It's just going to be flipped completely over. It's a reflection that looks exactly the same, just facing the other way. So that's all you're going to do for the shapes is you're going to make sure for each one you move it. And then it makes the exact same shape. So if you get done and your shape looks a little different and they're not the exact same shape and the same size, then you got a mistake somewhere. So you got to go back and check that. All right, now here's the examples where I was talking about where it could be different. Instead of reflecting over X or Y, we're now going to take this rectangle and we're going to reflect it across the line X equals 2. So this is the line X equals 2. So instead of counting to the axis and flipping over it, we're going to ignore the X and Y. Ignore them, pretend they're not there. We're going to take the rectangle and flip it over this line right here, X equals 2. So let's start with any point, doesn't matter which corner you start with. So if we want to start with this one, 1, 2, 3, 1, 2, 3. And if we go to this one, 1, 2, 3, 1, 2, 3. All right, and then what some people will do, they'll do all 4 corners, or wait a minute, if this is going to flip over this, it's going to look exactly like this. So some people will then look at this and go, okay, the top is 2 blocks wide, so let me just make a block 2 blocks wide. Because remember, it's going to look exactly the same, just flipped. So once you move 1 or 2 points, you can then just draw the shape. All right, so once you get more practice, then you start saying, oh, well, I got a point here, so then I can just draw it. Because you know it's going to look exactly the same, just flipped. Or some students just continue to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And they'll just go ahead and move every single point. All right, it's your choice how you decide to do that. All right, and then if we look at this one, we'll have sometimes when you'll have questions where it's not going to give you a graph. It's just going to say you have a triangle with point A is at 2, 3, B is at 4, 7, C is at 3, 8. It was reflected across the x-axis. So what's the coordinates of A prime, B prime, and C prime? So you don't have a graph. I would write this down, this shortcut right here, so you have it for your work. You have it for the quiz or the test when that comes up. So if you're reflecting across the x-axis, all you do is change the sign of the y. So if it said reflect across the x-axis, what this does, all you would do is change the sign of the y. So is the number in the front the y or the number in the back? Whenever we have a point, you need to make sure you remember that when you have a point, it's always xy. So the y is in the back. So if it says we're going to reflect across the x-axis, then you're going to change the sign of the y, which means you're going to change the sign of the number in the back. So all we would do is change, this is a positive 3, so when we write it down here, it's going to be a negative 3. This is a positive 7, so when we write it down here, it'll be a negative 7. This is a positive 8, so it becomes a negative 8. So all we did was change the sign of the y, the number in the back. Now, if this problem would have said reflected across the y-axis, then we would have changed the sign of the x, so then we would have changed the sign of all the numbers in the front. So that's a quick shortcut that when you have questions like these, that makes it really easy and quick to answer, because all you've got to do is, okay, change the sign real quick. All right, and if you notice, it's the opposite. So if they say reflect over the x, you change the y. If they say reflect over the y, you change the x. All right, so that's a quick shortcut that if you can remember that, if you write that down, then that will help you on some problems, because you'll know real easily, okay, I just got to change the sign. All right, and then the last type of problems we'll see would be, what if they give me a diagonal line and I want to reflect across that? All right, so that one, it's easy, but it's a little different, because if I looked at this, I couldn't just say, okay, I'm going to go diagonal and then count diagonal across. That doesn't work. So instead of doing that, what you do is, let's say we're going to move this point right here. Since we can't count diagonal to it, you can either count straight down to it or sideways. It doesn't matter. But what matters is when let's say you're walking this way, when you hit this line, you can't go straight down. All right, because let's look and see if we did that. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So if you try to just count straight to the line and draw your shape, this definitely does not look like that just reflected over. Because remember, it has to be the same exact shape, same exact size, everything. All right, so that doesn't work. So students start to, if they're messing up and they do it that way, you notice that pretty quickly that, wait a minute, my shape looks really weird. So the way it works, you count to the line, and then as soon as you hit that line that you're reflecting over, you have to take a turn and go the opposite direction. So like if I'm counting down 1, 2, 3, then I hit the line, instead of continuing to count down, I turn. It like makes us do a 90-degree turn. 1, 2, 3, 1, 2, 3. Same thing if I would have went sideways instead. 1, 2, 3, turn. 1, 2, 3. So let's do that for the other one. So let's try this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you notice it's the exact same shape. It's just been flipped diagonally over here. All right. Let's look at another one. Let me take this shape and I'll move it. And let's put it right here. All right. So we counted down last time. So let's do a little different. Let's count sideways this time and see if that works. So it doesn't matter which corner you start with. So let's say I start with this one. 1, 2, and then you got to turn. Can't keep going straight. So 1, 2, turn. 1, 2. And that's the only way to turn. 1, 2, because you can't turn here, because then that would put you still on the same side. We got to go to the other side of the line. So 1, 2, turn. The only direction to follow would be down or sideways. We can't keep going that way. So 1, 2, turn. 1, 2. So let's try this one. 1, 2, 3, turn. 1, 2, 3. This one. 1, 2, 3, 4, 5, 6. Turn. 1, 2, 3, 4, 5, 6. So exact same shape. It's just facing a different direction because it went from here and it flipped to the other side. All right, so that's everything for reflection. You're either going to get a dot for just one point, or you're going to get a shape. It's going to tell you to either reflect it across the x-axis or the y-axis, or it's going to give you some other line to reflect it across. That line might be a vertical line, it might be a horizontal line, it might be a diagonal line. And you could get questions like this one where there's no graph and it just gives you the points and tells you whether to reflect it across the x or y. Now the good thing on these won't give you, and it won't say reflect across the diagonal line. When you get a problem without a graph, it's only ever going to say to reflect across the x or the y. So you'll be able to follow the shortcut. So if you have any questions, you can let me know. The other classes that are in person for this, the other algebra class is doing all of these. You're not going to do all of these. Your next assignment, if you want to go ahead and work on it, is just going to be that first one. So if you want to get a head start on tomorrow's assignment, you can go ahead and work on IXL 8th grade P9, or you can wait. It's your choice. But that's it. So if you have questions, come to the Google Meet, email me, let me know. other than that, those of you that stuck around and watched the whole video, thank you. I appreciate it. I know we've got some students just saying they're watching it, but they're not really watching it. And that's showing when it comes to their work and their quizzes and their test scores. So those of you doing what I've asked, I appreciate that. And I will talk to you all later.